physics behind projectile motion in both the horizontal and vertical dimension. Make sure to hit that subscribe button and turn on notifications so you don't miss any of our new videos. So let's get started! After the discussion, you are going to describe the uniformly accelerated motion or the what we call UAM. And also, you're going to describe the horizontal and vertical motion of a projectile. Before we proceed to our topic, let's take a moment to review what you learned in your previous grade. In grade 7 physics, you already learned about the basic concept of acceleration, which is the rate of change of velocity. You learned that an object acceleration is proportional to the force acting on it, and that acceleration can be positive or negative. And during your grade 8, you also learned about the Newton's second law, which states that the acceleration of an object depends upon two variables. The first one is the net force acting on the object, and the next one is the mass of the object. So remember that the acceleration of the body is directly proportional to the net force acting on the body and inversely proportional to the mass of the body. This means that as the force acting upon an object is increased, the acceleration of the object is also increased. Have you seen real-life takeoff of the airplane? It involves the aircraft accelerating from a stationary position to a certain takeoff speed with a fixed distance. During the takeoff, the airplane's engines produce a constant thrust force that propels the plane forward, and this force causes the airplane to accelerate uniformly. When an object is traveling in a straight line with an increase in velocity at equal intervals of time, it is known as the uniformly accelerated motion, or also known as the UAM. In UAM, the value of the acceleration is constant. It does not change. The velocity changes, but at a constant rate. An object with a zero constant acceleration is said to be in uniform motion. An object in uniformly accelerated motion has no zero but a constant acceleration. And for you to easily understood, let us have a simple activity. So you are going to analyze each scenario, identify if it exhibits uniformly accelerated motion or not. The first one, a skydiver jumping out of a plane. Very good. That is UAM, or uniform accelerated motion. What about the next one? The cat sitting on the couch. Very good. It is not uniform accelerated motion. How about the next? Next, the rocks falling from a cliff. Very good. That is uniform accelerated motion, or UAM. How about the next one? The truck at rest. Very good. It is not uniform accelerated motion, or not UAM. Good job, everyone! Have you ever wondered how a basketball player can make a perfect shot? Or how a quarterback can throw a football accurately to a receiver? The answer lies in understanding the what we call projectile motion. A projectile motion is a form of motion where an object given an initial velocity is thrown or projected and is allowed to be acted on by gravity in a curve like a path. These objects are called projectiles, so the curved path followed by a projectile is called a trajectory. The UAM is closely related to the what we call projectile motion, such as the cannonball thrown into the air experiences a constant acceleration due to the force of what we call gravity. Projectile motion has two components: the horizontal dimension, which is the x component, and the vertical dimension, which is the y component. So they both play an important role in the what we call projectile motion. So let us differentiate the two components. The horizontal dimension describes the motion of the projectile along the x-axis, while the vertical dimension describes the motion of the projectile along the y-axis. The horizontal motion of the projectile is independent of its vertical motion. This means that the projectile moves with a constant velocity along the x-axis, while it is subject to acceleration due to the gravity along the y-axis. The horizontal velocity of the projectile remains constant throughout its trajectory, while its vertical velocity changes due to the force of gravity. So in the what we call the horizontal dimension glass, there is no resistance in any form. It has also constant horizontal velocity, and it has zero horizontal, and the horizontal distance is range. In the what we call vertical dimension, it is also known as the y component. It is free fall motion acted upon by the gravity. It has accelerating vertical velocity and a constant vertical acceleration, which is the gravity, which is also known as the AY. It is equivalent to negative 9.8 meter per second square. So the vertical distance is maximum height. Let us have some sample or real life situation. Are you familiar with this kind of sports? When the diver jumps from the platform, he has an initial horizontal velocity that remains constant throughout the motion. This is because there is no force acting on the diver in the horizontal direction, and therefore no acceleration. In the absence of air resistance, the horizontal velocity of the diver will remain constant until he or she reaches the surface of the water. This means that the distance traveled by the diver in the horizontal direction will be equal to the product of the initial horizontal velocity in the time and the rate. In this diagram, the man that dives is called as the projectile, which is an object undergoing projectile motion, and the dashed black line represents the path of an object, which is known as the trajectory. So the trajectory is the arc or curve like a motion path undergone by a projectile. Next is for the vertical dimension. So, have you seen an apple falling from a tree? When the apple falls from a tree, it has an initial velocity of 0 and is accelerated downward by gravity. The acceleration due to the gravity is constant and is equal to negative 9.81 meter per second on the surface of the earth. As the apple falls, the velocity in the vertical direction increases due to the acceleration of the gravity. And before we proceed to sample problem number 1, take note of these different variables that we are going to encounter. So if you see the VI, that is the initial velocity. The VF is for the final velocity. The Vx is for the horizontal velocity component. The Vy is for the vertical velocity component. A is for the acceleration. The T is for the time. The H is for the initial height, and the X is for the horizontal displacement. Let us have some problem sample here. So we have the sample problem number 1. A pool ball leaves a 0.60 meter high table with an initial horizontal velocity of 2.4 meter per second. Predict the time required for the pool ball to fall to the ground and the horizontal distance between the table edge and the ball's landing location. Now, if you see this diagram, so if we are going to illustrate the problem, let's say this is the height of the table, which is 0.60 meter. So we can denote this as the dy. So, the movement of the pool ball is projectile in motion, just like this one. So since the motion of an object is downward, therefore, our dy is negative. So it becomes negative 0.60 meters. Since the pool ball flew into the air, it has acceleration due to the gravity, which is negative 9.8 meter per second square. So, it is already our AY. So, we have the G. So, therefore, AY is equals to G. We also have our initial horizontal velocity. So, this one, the VIX. So, which is equivalent to 2.4 meter per second. Always remember, class, if the projectile motion is horizontally launched, or our VIY is always 0. So in this case, we are going to find for the time required to hit the ground and the horizontal distance between the table edge to the full ball standing position. So let us find for the given. So our dy is 0.60 meter. Our AY, or the gravity, is equivalent to negative 9.8 meter per second square. And our VIX, or the initial horizontal velocity, is 2.4 meter per second. And our VIY is equivalent to 0. So we are going to use this formula. So the dy equals to VIY t plus 1/2 AYT squared. You can cancel these variables already since the DIY is equivalent to 0. So to solve the t, we can use this formula. So we are going to divide the both sides with 1/2 AY. Okay, so you may cancel the same variables, so leaving with the t squared. So again, we need to find for the t, so we are going to square root both sides of the equation. So we already have our equation to find for the time. So we have the t equals to 2d divided by the ay. So all we have to do is to substitute for the formula. So we have 2 multiplied by negative 0.60 meter divided by the negative 9.8 meter per second squared. So the answer is yes. So it is 0.35 seconds. So if you are going to input this in a calculator, the answer will be 0.35 seconds. So we already have our time. So the next one is we need to find for the distance or the dx. Okay, so this is the formula that we are going to use in finding for the dx. Since ax is equal to 0, we can cancel these variables already. We already have our formula for the dx, so this one. So dx equals to VIXT. So let us substitute again the formula. So we have 2.4 meter per second squared. And we have 0.35 seconds. So the answer for that is we have dx 0.34 meter. Okay, so as easy as that. And for you to try at home, so let us have some assignment. Okay, so you may answer this on your notebook or any piece of paper. A soccer ball is kicked horizontally off a 22.0 meter high hill and lands a distance of 35.0 meters from the edge of the hill. Determine the initial horizontal velocity of the soccer ball. So that is your assignment. So remember, class, please remember that everyone, God is a God of order and precision. The laws of physics are not random or arbitrary. They reflect a deliberate design that governs how the natural world works. And the fact that we can understand these laws and use them to make sense of the world around us is a testament to God's intelligence and creativity. Again, God is a God of order and precision. And that's all for today. Thank you and God bless everyone. See you on our next video lesson. Thank you, everyone.